Okay, let's pick up where we left off and go for an hour and a half continuously, and then we go, right?
Oh, yeah.
Is that the rule?
3.
3 o'clock. I promised 3 o'clock. I got my watch. I'm ready to go. So, luckily we don't have to start from the beginning on this lecture. We can pick up where we left off. And you know what I'm going to do in the essence of giving this material the proper attention? I'm going to wait and do the examples tomorrow. So the source code examples will happen tomorrow. I just want to go through this particular lecture and then cover the next one, which is all a lot of theory. But so you'll have opportunity if you bring your computer tomorrow. We're going to go through all of the source code examples. Because some of you I know don't have computers with you. So if you're anxious tonight, you can actually go home, install Java, get it all set up, and then tomorrow come. If you don't have the development environment. So it'll be advantageous if you're brand new to this to actually do that, to install everything, get it ready to go. Alright, so this particular lecture started out talking about static, which we covered, and then we looked at this example with a pencil and a create pencil with the driver program and with the class that we're using. And also keep in mind that although this example is only using one class instance, we can create pencils, pens, erasers, all sorts of different other objects inside of create pencil. We don't have to use one driver program for one class. I only mention that because I did have a student one time thought that, and I kept seeing all these driver programs. I'm like, what in the world's going on? So no, you can actually put more than one instance of different objects in one class. It makes sense to do that, actually. It doesn't make sense to have a bunch of driver programs. Note this code is only for the purposes of showing the usage of static. It is really poor design. And as I mentioned before, why it was poor design? Well, probably because here we're not using any public. No, what are we doing in here? Oh, here's what's going on. Let me point out why this is bad design, actually, which is a good point. We're printing stuff to the screen 1, 2, 3 times. We are, what are we doing? Next ID. Going back to what I originally said about these classes and the data members and the member functions and how they're supposed to work. This, although it works, and you might look at this and go, I don't know what's wrong with this. It looks pretty good to me. What could possibly be wrong with this source code? Well, I can tell you what's wrong with it. So, most of this can be put inside of the class and not in the driver program by using what's called a constructor, and that's the focus of the next lecture. The constructor would go ahead and take an increment next ID. The constructor would go ahead and print something to the screen and do everything except for, the necessity of actually creating the object. So we could create the objects and use the objects in the driver program and put all the other code in the class itself. So the objects, you want to make the objects feature rich. You want to have them go ahead and get their stuff, print their stuff, and do all of the behavior, all of the work. And you want the driver program to just make instances of objects and run methods on objects. And what I'm talking about here in terms of making an instance of an object, and I didn't really go over this, so I'll spend a few minutes going over the syntax. It's just like declaring variables in the old days. We said integer I, float j, or whatever. This is pencil P1. Pencil's the name of it. When you're creating objects, you're actually creating data type objects. The data type is an object that you're creating. And so pencil P1, that's the data type. It's a pencil object. And we want P1 to be the name of the pencil. And it's going to be equal to new pencil. That I can't explain to you. In fact, it seems like C++, actually. The new, the delete. We don't have delete, though. We just have new. So it's supposed to be a new instance of pencil. And the interesting thing here is you can have pencil with nothing, and it would be running a default constructor. You can run the same identical code and put parameters in here. As long as you have a function inside of that class that takes on that number of parameters in that order, then that will run. The class is pretty smart. When you make the instance, it finds the default constructor, it finds the constructor that you're intending to run, and it will run it for you automatically, which is kind of interesting. And so, as I pointed out, most of this stuff, these 2 lines of code, these 2 lines of code, don't need to be repeated. They could actually be in the constructor. So when you made the pencil, it did all this stuff. So, and yes, the method itself inside of the pencil can print itself out. You just call the method, essentially. Word about final modifiers. Final, once initialized, the value cannot be changed. It's kind of like constant, as I mentioned before. So we have static modifier, public, private, all that stuff protected. Little thing here, hardly ever used really, but it's used for constants. It's often used for defined name constants like pi is equal to 3.1. It's never going to change, so you make it final. Non-static final fields must be initialized when the object of the class is constructed. Can you imagine why? If it's final, you can't initialize a value to it. So you have to actually initialize it with final. So oftentimes you'll see final static pi is equal to something, or you know, I don't know. You'd see it used a lot for, you know, constant variables. Field initializations, another thing to note with the float versus the double, you have to put that F sometimes. In fact, you probably saw it in this example. Usually I have one or two students that points it out up here. Here we go. But I didn't actually go over this part yet, which is why you didn't point it out. You didn't see it. But if you did, price is equal to 0.5, and this was a double, it would work just fine, actually. Because this F is going to typecast the value to a float, don't actually have to do this. Not in every compiler, not in every environment. This is just done to specifically state that this is a float conversion. Java actually does an automatic conversion. If you say integer I is equal to 1, well, I is going to get converted to an integer. And so if you said I is equal to 1.0, it's still going to be 1. And it's an automatic conversion. So you don't really have to worry about that, but some old style, they want to explicitly cast it to a float value. And just to finish up this example where we know this doesn't work. It just doesn't work because this is a static, price is a static variable. Yes, it is. No, it isn't. Next. Pencil P1.price. What's wrong with P1.price? Float. Private. It's private here. That's why we're doing it. It's private. And we could also mess around with static. If we said P1.nextID, that would also give us an error. This example, I forgot it's trying to point out private and protected. But we would also have the same problem if we did P1.nextID. But if we did pencil.nextID, we wouldn't get an error. Because if we're using the keyword static, just to review, it's for a class level, so we have to call it from the class. We can't call it from an instance of the class. Alright, we already went over static. Final, we already went over final. Field initializations, pretty straightforward, just like C, C++ actually. If no initialization, then the default initial value is assigned depending on its type. That's where I said if you left out this F, it would be the default of a float. And if they make any much more noise next door, I'm going to go over there and tell them to knock it off. So we'll see how far that goes. The declarations itself, we have method declarations in two parts. So the method header, constant modifier, optional. Constant modifier is a public, private. It's optional actually. Return type, method name, parameter list, and then perhaps a throws clause, also optional. We have an entire lecture on exception handling, and we'll see how throws is used in terms of the syntax and what it's used for automatic exception handling. So types of modifiers, we looked at this. We didn't really look at this. We looked at some of the things. Abstract, static, and final are some of the static one. It represents the whole class. So note, a specific object can only access static fields and only static methods of the same class. If we make the class in terms of the method static. So if we make the class static, we have to make the method static as well. A little word on abstract concept. An abstract class is equivalent to the .h file in C++. So if you're not familiar with C++, just ignore what I'm going to say. But if you are familiar, and if you had one of those old-fashioned teachers that taught you how to do implementations and specifications, and you hated it, you don't have to worry about it. You're not going to have to do it again. But the abstract class is equivalent to the .h, the specification file, whereby, if you remember, you had to include stdio.h and iostream.h, and what you did was you included the header or the spec. The spec didn't have any bodies, didn't have any implementation, and didn't have anything. Instead, what it had was just the, C in, C out, all the names of all of the different classes and methods and everything that was in there. And then there was an implementation file, a .c++ file that was created. And same thing with Java. Once you compile those, they're called pre-compiled headers, which means they are already class files or they're already executable files, and you just don't have. It's object code in C++. It's .o files, and the compiler will just look inside the .o file and find it when it needs. It doesn't have to recompile it again, so it makes it run a little faster. And you included the .h file because we needed to use a function that was in there or something. In the Java world, we create abstract classes, and then we implement abstract classes. And we can have the concept being, if you create an abstract class, the implemented class has to implement method bodies for everything. So all of the methods have to match. It just, for standard purposes, for making sure that things get implemented correctly. It's also used for enforcing rules. If the shape has an abstract class, then you have to abide by all of the different shape stuff, and you have to implement all of the different. It's going to use an abstract class, and it's going to implement all the behavior. I will have an entire lecture on abstract classes as well as interface classes. The interface is interesting. We don't have this in C++. We do. I think it's the template, isn't it? I think it's the template, if I remember this right. Trying to compare languages. In Java, the interface is a way of getting multiple inheritance. So we inherit one class from another class. We extend one class behavior with another. We implement an interface. We add multiple levels of functionality to that class that come from more than one source. So in the inheritance, and we'll spend tomorrow, we'll look at inheritance. We'll take a look and we'll see how one class can extend, and then the keyword extend is actually used, which makes a lot more logical sense, I think, than C++. We'll see how that specialization is created through inheritance. And then the purpose of interfaces, we'll probably get to this at the midterm, at the middle class, next class meeting, where we can implement multiple interfaces, so we can make a shape have different characteristics that belong to different types of shapes, as an example, instead of just one. So it has a little bit more flexibility. It creates multi-lined inheritance, actually. So it's a little different, though, because we're not really inheriting anything. We're interfacing, which means we're using a template, essentially, to spec out certain behaviors that we want this new object to actually contain. So going back a little bit from stuff I've already kind of assumed you knew, but we're going to go over the formal presentation of it, the methods in invocating a method. It's called an invocation, not an instantiation. So we instantiate by creating a new instance of a class. We invoke a method for an invocation. We use the dot notation. We usually invoke, and method invocations are done normally on instances of objects. But as we saw with the static, we would invoke something on a class. So it's always a reference of this object that we've created, a dot, the method name, and then the arguments. Just sort of like running a function in a lot of ways, but they're not functions. Well, they are functions. So it's kind of like running a function if you think about it. Static methods outside of the class, the reference can be either a class name or the object reference belonging to the class. Inside the class, the reference can be omitted. So we don't actually need to do a reference inside of a class. That's how come we see these variables all the time. We just say color. Color is equal to blue. Color is equal to red. Where did color come from? Well, it's inside of the class. We know about it. It's in the same scope. Non-static methods, the reference must be an object reference for anything non-static, and that's the thing you normally see. Method overloading. We have overloading and overwriting. We all know overwriting. When we save something and we change what was previously written. and that creates a new version that's modified. We overwrite the previous version, we change it completely. Overloading is where using the previous version, it's kind of like track changes, or when you merge, we're merging multiple changes together. So we have what was there before, what we added to it now, and what we added to it in the future. Overloading happens with inheritance, and it creates polymorphism. And I can never say that word right. But anyway, in theory, and I'll talk about those concepts in a few minutes. So a class can have more than one method with the same name, as long as we have different lists of parameters. So inside of the class itself, we are overloading when we create a constructor, essentially. The constructor, just like in C and C++, has the same name as the class. In fact, it's the same principle. You have multiple constructors. The one that doesn't take on parameters is the default. The other constructors just have different number of parameters. And that actually creates polymorphic behavior, because we can create and run something and send it a float. We can create and run a method and send it an integer. It's kind of like C in and C out, if you think about it. That's polymorphic in behavior. We C out a sentence of text, we see out a number, we see out an object reference, and it changes and it adapts every time we give it an input. It changes and runs a different method. That's what the constructors are doing, essentially. It's polymorphic behavior, which adds polymorphism into, I think I said it right, into the object-oriented language. But in this case, what we're doing is we're overriding. Here, set price, it's not a constructor at all. It's just a method. We can do this all the time, so then going back to what you were taught when you learned C, before you learned object orientation, they say, oh no, you can never repeat the name of a method. Or actually back then they called them functions. You can't have two functions with the same name. Oh, sure you can. So erase that from your memory as well. Which I think is the reason why a lot of people have a hard time learning object orientation, because it contradicts everything else you were taught previous to that. You take all these rules and break them all and get rid of them. You start fresh. Which is why people who learn object orientation first end up learning it faster. Because they don't have any of this baggage carrying around all these rules that they're supposed to remember. So they just break them and they don't even know that there was an actual difference. So when you create two methods with the same name, different number, you're overloading. We overload constructors with each new inherited class. We add behavior to each constructor that is only particular to that particular class. You can tell an amateur Java programmer, well, number one, they never use constructors. But number two, instead of overwriting, instead of overloading, they overwrite the constructors. Because number one, either they're afraid of the constructor order and they can't control it, or they don't realize what they're doing is overwriting and they're not overloading. So amateur, actually it happens with C++ all the time too, amateur object-oriented inherited, people who write inherited classes, overwrite everything. If you're going to overwrite it, you might as well just create a brand new class, right? Not even use inheritance. You're defeating the principles of inheritance if you're just going to overwrite everything all the time. It's like, here's a blueprint, so instead of using this, I'm going to rewrite it. Okay. No problem. I'm not going to use anything on the blueprint. All right. That's not really inheritance. So how does the compiler know which method you're invoking? Well, it looks at the number of parameters and the order of the parameters. You can have the same parameters in a different order and write it that way. So you can actually create a pretty flexible polymorphic type of behavior with that. And it compares the numbers and the type of the parameters and uses the one that matches it. So parameter values. Parameters are always passed by value. Let's go back to pass by value and pass by reference from those rules you learned in C++ and all the differences that you had with arrays and structures and objects and pointers and all that stuff with the passing as parameters, and scratch all that stuff from your memory. In Java, when a parameter is an object reference, it is an object reference. It's passed by reference. Not the object itself getting passed. It's a reference to the object that gets passed. But we don't have pointers. So how do we have pass by reference without pointers in a language? It's built in for us. So we send the object, and it's always passed by reference. What happens with the object stays with the object. You know, object is the. It's kind of like with the side effect that you had with arrays. You sent arrays to a function, and then the body of the array got changed. The contents of the array got changed, and then outside of the function back in, hey, the array's all changed up. Well, we get this automatically, so makes method calls a lot more effective. We take the object, we send it to Las Vegas. It goes and it wins $200. And then when it's done with its vacation in Las Vegas, it still has its $200. We don't take it away. It gets to keep it. Gets to take it home with them. So it comes back to Maine and it can spend the $200 on grocery shopping or whatever later on in the program. So the life existence is a true life. There's no reference. There's no value being passed. It's always a reference. We do have pass by value, and by default, anything outside of an object reference is always by value. We can't pass it by reference. And then some people usually wonder, well, what about all the advantages of passing something by reference? What advantage was there really? Memory? Maybe because you didn't have to make a huge old copy of something and send it. But we're working on a JVM. Memory is unlimited. And it's garbage collected. So we don't have any of those problems of speed and efficiency that we would have normally used a pointer with in the old days. That has all gone away. So, not that we were looking at pointers. Most people don't like to use pointers, so they have no problem with that. Here's another example, and here's a bunch of examples here actually showing, and I got some better ones to show you on tomorrow. But this is just showing you the different object, right? You know, P dot color is equal to red, and all the different format from where this is coming from. Paint red is a method call, and we're sending it this. It's just some examples. So you can change any field of the object, which the parameter refers to. The object is changed for every variable, and it holds the reference to that particular object as well. So basically going back to that pass by reference instead of pass by value concept. And don't worry if you don't get this concept, if it doesn't seem clear to you, because it will when you start passing passing objects as parameters. And then you see the side effect and you go, oh, that's what she means. So the main concept, the main method concept, we still have it, but not every program has it. Not every source code file has it, like in C or C++. The main method, the system locates and runs the main method for a class when you run the program. In Eclipse, as we saw right before the break, if you have a main in there, it will be the driving factor, the driving program that will compile or look for object references that are contained and compile everything for you. It will actually be the one that runs as well, although you have to explicitly tell outside of Eclipse, and we actually just noticed on her computer, in Eclipse it actually will run the main method inside the project, which is interesting. And it probably just runs the first one it comes to. But in the real world, you would actually run, you go Java space the name of the driver program if you wanted to run it. Other methods get executed when they're called by a main, and the methods explicitly or implicitly must be public, static, and void. Main never returns a value. Main has to be void in Java. It doesn't, again, it changes all the rules in C++. In fact, you know, for the longest time when we had Borland C, we had Turbo C, and all these other dialects, we always had void. And then we got Microsoft, who gave us integer main with the return 0. I could never figure out why I didn't want to just leave it void. I don't know. They made the compiler like give you an error message if it was void. You had to actually put integer. I hope they have removed that because it would be a big problem in C++ these days, but has to be public. Can you imagine why? It's got to run. If it can't run, if it can't be seen outside of the class, you can't run it. So static, yeah, it has to be static. It's the class method that's running. It's not an instance thing. It's a program that's running. Getting input from the command line. Remember everything you learned in C++ or C about command line arguments? Type in the name of the program, space this, space that. It's a string. You'll see some of the some of the examples that I have are using this, and some of them aren't. I like to leave it out, actually, unless I'm taking in arguments, but yeah, I don't know. Some of the source code examples just naturally have that. You parse it the same way as you do. The rules are identical to C, actually. It comes in a string array, and you parse out each one of the things, words that are separated by spaces. So when running the program through the Java command, you can provide the things that the strings are as real arguments in the main program. Then you can use them inside, essentially. Greetings, Jack and Mary. Hello, Jack and Mary. So you're getting strings. Modifiers of the classes. So a class can also have a modifier. We actually haven't seen that in any of the examples we've had so far. Most people would by default put in public. If you're going to put in public and you don't like putting in a modifier, you can leave public out. If you leave it out, it's public, which is the default behavior. So public can also, public is publicly accessible. Without the modifier, a class is only accessible within its own package. That's the one caveat there, which is why, again, as another standard Java programming practice, you'll always see people using public. Even though you don't really have to put it in there, you could just say class employee. There's no requirements. But if you're going to start using packages in the future, thinking that you're going to grow, you're going to start moving stuff around, you start sharing your class files and have multiple people working with you, it's not going to work. It's going to screw up the package. It's not going to work properly. So, abstract. No objects of abstract classes can be created. Going back to the abstract concept, it's sort of like a template. It's sort of like abstract classes are the blueprint. And here's the interesting thing, and this is a lot of people actually kind of can get it in this way. And remember in C and C++ where we had a function prototype? Because unless you put all the functions first, you had to actually put a prototype up there and say, hey, I'm going to have add function, I'm going to have this function. And then down in main, you actually made those function calls, and then below main, because it was all functional, you had function implementation. So the abstract class is sort of like the prototypes. I hate to call it a template because that's really a misleading word. It's kind of like function prototypes, though. It's kind of like putting everything, and you're not ever allowed to put in any sort of method body implementation. It has to be empty, just like a prototype. You do that because you're trying to structure the inheritance. You want to make sure that each class that's written from this abstract class implements these methods because it's needed for something, probably from the inheritance further down the road. Even if it doesn't do anything at all, it still needs to be implemented. All of the abstract methods must be implemented by its subclasses, and otherwise the subclass must be declared abstract also. So you can have an abstract subclass of an abstract class. If you do that, you're setting up a foundation that you're going to implement on. So it just means you're not going to implement it now, you're going to implement it in the future when you subclass it. Final cannot be subclassed. Obviously, it's final. And you can say final class. What does final do? It ends the inheritance. It stops the family tree from growing. When you're done, you're done. If it's a boat, it's a boat. Finalize it. Next time, make a car or a jet ski or this or that, other kinds of things. Normally, a file can contain multiple classes, but only one public one. And the name of the file and the name of the public class must be the same. We saw that already. What we're looking at in terms of bad programming style, if you wanted to do things poorly, not best practices, then what you could do is put everything inside of one text file. As long as you only have one public. If you don't give them access methods if you're going to be that sloppy. Just cut and paste all of your classes, put them in one text file, and it will work. Which is, you can do the same thing in C. In fact, you don't need header files. You don't need .h files and implementation files in C. You can just put everything in a C++ file and compile it. But that's kind of sloppy too. So depends on the goal, I think. I thought I had the other lecture open. I guess not. That was lecture number 2 in the trash. Lecture number 3. It's only 23 slides, don't worry, we'll get out on time. We might even get out earlier. Depends on how fast I am. Lecture number 3. Object creation. Okay, so this is going to go through constructors, object creation, and some stuff I've already talked about, which is why I think we might actually get out pretty on time. We've already seen that the body sun is equal to new body. We've already seen, this is word wrapped, by the way. The end of this is over here on top of the screen. So an object is created by the new method, as we've seen. The runtime system will allocate enough memory to store the new object automatically for us. No dynamic memory allocation needed on our part. If not enough space, the automatic garbage collector will actually come out and remove something that hasn't been used recently, which is the least recently used garbage collection algorithm, if it actually is that short of memory. If it can't pull anything out, everything's being referenced, and there's no memory available, you actually will get an out-of-memory error exception. Rarely happens, actually. Rarely. You see this usually on mobile devices, when it seriously has run out of memory. No need to delete explicitly, so there's no delete. So let's talk a few more words about the constructor. And the constructor is a way of initializing an object before the reference of the object is returned by new. It's automatically evoked. There's no way to run a constructor outside of creating a new instance of a class. It has the same name as the class. You don't have to use the constructor. You can have a method. And if you have a method that does stuff automatically, you have to run it manually. Why run it manually? Just run the constructor. And you can have the same access modifier as the class name, as the class members, obviously. Similar to methods, the class can have multiple constructors as long as they have different numbers of parameters, and they have no return type. A constructor cannot have a return type, because nothing's going to be returned anyway. They have to always be void. Constructors will, with no arguments, are called non-argument constructors. I don't know. I call them default constructors, because that's what they call them in C or C++. So, if no constructor is provided, the one without the arguments is going to run the default constructor. Same behavior as C and C++. Here's our constructor. And you might notice we've left off all of the access modifiers. Just says body. You're like, body? Class, body. Nothing in here either. I guess we could have left all this stuff out too. But this is showing you the better design. This is showing you the private data members and the public member functions. If we leave it off, it's by default public. So we could just put public class body, public body, public body. And then when we have two same names, different number of parameters. And then we have this. I don't actually like to run this. I like to run this dot name, this dot orbits, and we'll see this dot. Where'd it go? Here it is. This is what I like to do. But you may not like to do that. You might like just to put the word this up there. What is this? Inside the constructor, you can use this, to invoke another constructor in the same class. Used differently in context, but it is the same concept when you put this dot name. This dot name is talking about this dot name, this object's name, this constructor. So in theory, it's kind of confusing. Well, it's not really confusing, but it's kind of textbook. So this is called the explicit constructor invocation. It must be the first statement in the constructor body if it exists, and this can also be used as a reference for the current object. It cannot be used as a static method. We don't have any thises. Do you know why we don't have any static thises? Because this doesn't belong to this instance. There's no this. It's that. But there's no that. So going back to the example, and I thought I heard a question a second ago. This is going to say run this constructor. Why do you need to do that? Well, because perhaps you might have an inheritance going on. No. Just make sure to run it. Yep. Constructor will only run once. You can leave this out and the constructor will still run. unless we've got some inheritance going on and we want to run something first. Explicitly say, run this constructor. Imagine the possibilities. We have a body, and then we have body parts that are created, I guess, from bodies. And we can, actually, here's the example here. It's going to show you the difference. We can just say, run this one, run that one, run this one. And it explicitly invokes the constructor for us. So assume that no anybody object is constructed before. That's so bad. No anybody object. When we say body sun is equal to new body, then we have sun, ID 0, null, next is 1. We already learned about this one. In fact, this is the proper way of doing it. We're not incrementing this out in the driver program. We're incrementing it in the constructor. Assume no anybody object is constructed before. And then we have body sun is equal to new body. Here we go, we're going to run this one. And then body earth is equal to new body, earth null. So now we have next ID 1 and we have next ID 2. So then we have the items set for the both of the two of them. So we've run the next we've run this one as the default, and we've run this one. So we're running them both essentially. So this is going to say run it. I don't actually by habit, I don't actually do that. I leave it out. And then I just design the constructors to fire the way I want them to fire. Because, think about it, anything you don't want to put ID number down here too. I'll just put it down here and run it once. Just run it, you know. I mean, I don't know. I guess that's repeated code, so in terms of style. There's some rules that are, you know, I don't agree with in terms of how people do stuff. This is interesting because we just saw an example. Here's a usage of this as a reference of the current object. So we're talking about this name, this arbits. You might be wondering, well, what do we need to do with this? Well, what if we've got another, and this is what I was talking about inheritance. What if we've got body parts 2 or body 2 that's inherited, and we got 2 names and 2 objects from 2 different references from the object? Because, you know, one object can be that object, but it can also be another object. And we have one of our assignments where we're going to have a person who turns into an employee, who turns into a staff person, who's also a person. So if we wanted to say inside of the person object, we would say this name, this object's, this person's name, or the staff, inside of the staff, we could say this person's name. It's all name, but which object are you referring to in terms of the reference? And so you put it inside of the class implementation to say this one. So, again, you may or may not, well, actually, you will be using this. You'll be required to do this in one of the assignments, actually. I think it's the second one when we start working with inheritance. And you'll see it. It won't work without it. So you'll see it. It's kind of tricky. And not tricky, it's kind of interesting when you see it come together and you go, oh, that's what makes it work. So it's kind of fun. That's what's interesting about programming in general. It's kind of fun to see it come together once you learn a little bit of the rules. So, other initialization methods. Okay, this is, again, not necessarily what you want to do. You don't have to use constructors. You can have what's called an initialization block. So in the class, without the initialization block, we've got the data members, we've got the constructor, we've got another constructor down here, and we got this going on. This is the same thing we had before. If we wanted to put where does this come from? I don't know if you guys can see that. It's not a method. It's nothing. It's an initialization block. This is kind of like, this is really, in my opinion, poor practice. Because this violates inheritance. I mean, when you inherit, there's no way of controlling this. It's always going to run, regardless. So block statements to initialize fields of the object. This is as bad as putting it up here, actually, in my opinion. It's legal. You can do it. Outside of any of the members are the construction declarations. So it kind of just says, hey, you know what, forget it. We're not going to use a constructor. We're not going to use a method. We're not going to do anything. We're just going to stick it right here. The problem is I see students doing this far too often. And you know what? You can actually violate all the rules of the class and put everything, no methods at all, and create the object. And I've seen students do this and I go, whoa, why? They say, pencil, create new pencil. And then new pencil gets created, it gets initialized to this, it gets into that, and this happens and this happens. You can actually put the entire program right here. All the stuff that belongs in the driver and in the class and everything. Why? I mean, I don't know. It's abuse. You're not following any standards. So they're executed before the body of the constructors. Oh, that's great. Why don't you just have the constructor do it? But it's in there. For very, very weird reasons and workarounds, it works for problems. It's a fix. It's like a Band-Aid on a problem. Static initialized blocks. Let's take it a little bit further. We can make them static too. So it resembles a non-static initialized block, except for the declaration of static is used here. So it's just like a block. You put static in front of it. It gets executed when the class is first loaded. Okay. Packages. We know about packages. Do we know about packages? I don't know. We're going to see packages tomorrow when we start looking. We're going to import some packages. Classes can be grouped into a collection called packages. Java Standard Library consists of a hierarchy of packages, such as java.lang and java.util. I don't believe Eclipse requires either one of these two to be actually imported or used. It assumes if you're going to write a Java program, you're going to use lang. Where else are you going to get system.out.everything and all the other methods and all the other objects that you're creating? They're coming from lang. It's the basic core language. Util is going to give you some math stuff. Oh no, actually there's a math for that. It's going to give you utilities. If you go to this link here, it's from version 1.42, kind of outdated. Interesting thing, one of the important things to note among all the different packages, and this will cause you problems when you cut and paste source code examples off the internet, major package name changes. Inside, not the package name, but the method calls and the objects inside of these packages. The entire I/O switched around at one point. Math functions, a whole bunch of stuff is not very standard. So what ends up happening is you go look at that and go, oh, this is for 1.4. Oh, it's not really backward compatible or forward compatible. So you find the right JV. In fact, that's one of the reasons why all of them are still available. Because you got an old piece of source code you're trying to do, and you're going to find the JVM and you're going to find the JDK for the right version of that code, and you're going to compile it with that, and you're going to run it with that. Otherwise, you got to have to go through and edit the entire program, change the names of some of those objects and methods. And I said it's only really about 10% of them, but they always seem to be the ones that are in the program examples I want to use. So, main reason to use packages is to guarantee the uniqueness of the class name. Kind of the same thing you use with the include section. Actually, no, I should rephrase that. This is sort of like namespaces. You guys familiar with namespaces in C, C++? You create a namespace, you put a bunch of files in it, a bunch of libraries, and then you using namespace std or using namespace my namespace. Because you used a driver for a printer, and someone went and called it cout. And so now you have to tell the compiler, not this cout, that cout. So you changed namespaces to include different sets of libraries. That's what the package is accomplishing, actually. One of the things the package is. It's also accomplishing some organization in your code. And it has to deal with the directory structure, believe it or not. The code is actually stored in the package in terms of how it's organized on the drive when you're using it. Packages with the same name can be encapsulated in different packages. And the tradition of package names reverse the company's internet domain name. Nobody does this anymore. And here's an example: com.hostname. Actually, they do. You do see packages like this. The open source stuff. You see it in this format. It's kind of an old tradition. Reverse the domain name. And there's your package name. Package importation. Two ways of accessing public classes of another package. Explicitly give the full name before the class name. We haven't seen this yet, but java.util.date. Well, that means we want to use the date inside a util. Today is going to be equal to, and this is interesting because you can do this yourself. You can create your own 25 different dates. Put them in your own package and then go java.mypackage.date 1, date 2, and you can have different package names and put them in almost like organizing the file manager. That's why I always call it like similar to a directory structure. You're just putting it in a different location. So you can use 25 dates all in different package locations, and you can pull the right one out when you want to create an object of that type. So here I have new date. I'm just calling the method on the date. Or you can import the package by using the word import. So at the beginning of the source code, and we'll see it in the next example, we have the import statement at the top of the source code file, but below the package statements. No need to give the package name anymore when you start using them. So if you said at the beginning import java.util.date, you're just importing date object. You're not importing everything else. Normally you won't see this. You're going to see this instead. You see this when there's more than one date. You have two packages with more than one date, so you want to know this date, and then you do this on the other one. Now give me everything over there and just give me this date. So you can figure out what you're doing. To import the public, everything in here. The asterisk is used to say the current package level. It will not import packages in sub-packages. So this is kind of funny. In fact, it's kind of ridiculous. Sometimes I see it like out like 5 or 6 different lengths, and then I see the asterisk at the end. And then you see it out, you see the asterisk at the end, and you see that. And you go, what did they do? Just cut it short and put the asterisk there and include it all. Because it's just like the includes. If it's not in there, it's not going to be used. But that might be going... It's not going to add any weight to your program, is what I meant. It's not going to make the program bigger because you imported all this stuff. So then you get people with reverse thinking. You look at the top of this code, and it's like 20 lines of packages. It's like everything they possibly wrote in their entire programming career is up there. And you can spend, I mean, it doesn't really matter. It doesn't add anything. But who knows, you might be using something somewhere in there. And so you put it into the point where you're going to be using it. Here it is. Import java.swing, javax.swing. And we will actually look at AWTN swing towards the end of this course. Public class, sample class is going to use menu event C. So. And we have an error message. Can't find the symbol. Sample class. We're going to hear menu event. Oh, can't find menu event. One error. Menu event is a class in the package. Ooh, it's an event. Well, we didn't include event. We just included swing. So it's not going to find sub-packages, is what this is saying. So we have to change it so it says event on it. This is why you see the whole string of 1,000,000 of them going out as far as it can. And then they put the asterisk at the end. It means all of it this way. Okay, class importation. What if you have a name conflict? Well, here's how we resolve it. We're going to have a name conflict here because we have util and SQL both have a date in it. One of them's for SQL queries and the other one's for utilities. So if you only need to reference to one of them, import the one that you want explicitly. So here we have this one going in. So we can put, this is what I'm trying to say, we can put this in, we can put this in as well. We can put multiples of the same. If you do this in C++ with includes, it'll say, sorry, I assumed that it's already in there. But you can't, it's a different format, different concept. But don't be afraid to use the same thing twice, 3 times, 4 times. If you're trying to go to different packages. But if you don't explicitly need the date, what I'm saying is don't put this in. Unless you've got 2 dates that you're having to deal with. But in general, what you're going to end up doing is cutting it short. So you've got an import java dot something with an asterisk on it. That's what you're going to end up with. So if you need to refer to both of them, and you have to use the full package name before the class name. So here we've got java.sql.date today, and then we've got java.util.date next day. So you've got both of them going on. See this code. I see this code. It has math in there from language. Which is kind of interesting because you actually have to include, you don't have to do it for basic stuff, it's just if you want to use the function, the methods for square root, for rounding and stuff like that, then you have to put the math in. And then we have, well, let's see, we're going to compile this program. And it says, what's this? One error. The static members, you need to refer to them as class name.member name. So we have to actually go back because we have a static in here. So we actually have to go back and refer to it as from the class name and not as we've got here. So we have to go actually math.square root to fix it. I'm sorry? We got to refer to the class name. For the static members, you need to refer them as class name.member name. So it knows math. Math.squirt. You have to put math here. Dot something. You'll always see math.square root, math.round, math. Which is the actual class name. These are actual classless class packages, so that's what it's referring to. Which is a common thing that you're going to leave out because you're not going to think of it. You're going to think of it as a package, not really a static. And math, or the math class is all full of static. So you're going to go around it a couple of different ways. You're not going to use statics in yours, and you're going to remember which ones which ones are static. And then you'll use the class name math.square root. And it's actually, believe it or not, turns into sort of a, there's only like maybe 5% of all of the packages that are going to give you that. So actually, no, there's a util.date. There's a, yeah. You'll find out when you start looking at it. And then here's another interesting thing on the static importation. You don't have to do it anymore. Java SC, this is what I was trying to tell you, between all the different Java versions, and this is where you have the biggest headache when you're trying to use somebody else's code. When you're trying to download an example and use it, or you're fixing a program for a company. Importation can also be applied on static fields and methods, not just classes. So you can directly refer to them as static importation. So import all static methods and methods of the math class. Oh, now we're going to use import static java.lang.math. Give me everything, and then we're just not going to have to worry about that problem. Import a specific one. We've got abs here. So any version of SE5, and we're actually in 6 right now. Does not have this feature. Before 5. Actually, 5 changed the system, added some system I/O, added a few different varieties of the input out of the output, the system out, and did something else. Added a couple of new methods in there as well. So, if you have an old Java book based on a previous, I would go 5 and above. 5 is where all the significant changes ended up. Going back to the Deedle and Deedle, none of those changes are really going to affect the basic stuff. So some of the Deedle and Deedle texts, which is the reason why you can get them for $5 or $10, it's based off an old version of Java. And every 2 or 3 months we have a new version of Java that comes out. And you know how textbooks work and how the market, oh, it's old. But for the purposes of what you're learning, that stuff hasn't changed. This stuff's still the same. Which the inheritance hasn't changed. Nothing, abstract stuff didn't change. The only thing that changed was, oh yeah, a new package added. Of course they're going to change the packages around. But as a programming language, I don't think I've seen any other language change so quickly. Like C++ never changed like that. Java is like, oh, where'd you get that from? Brand new language. Encapsulation of classes inside of a package, adding a class into a package. We have 2 steps to do it. We put the name of the package at the top of the source file here. We got the package com.hostname.core.java. And then, actually, that's a pretty cool package, actually. It's got a bunch of good examples and stuff in it. And then we have public class employee. That's part of this. So we just start excuse me, that's going to use inside of here, we're going to use something in there. So we put the files in the package into the subdirectory, which matches the full package name. This is why I'm going back to the comment I meant when I explicitly kind of gave you the idea. It's all the directory. And you can kind of think of it as where you're storing the files in the directory structure, is how you're importing those packages and what you're using with that package. So the package itself stored in the file java. So stored in the file java.employee.java, excuse me, which is stored under some path com host name core Java is where you're going to store it. Eclipse will do this for you. So every time you create a new class file, I say, what package do you want it in? And you probably noticed it gave me it complained about the default meant no package. I didn't want to use a package because I didn't talk about packages yet. And it says, oh, this is really bad. A little warning comes out. Not good practice to use the default. No, I'm violating the feature. I'm not using it. So you may, at your liberty, create your own packages, use your own packages. You might find it helpful in remembering where stuff is. I've had students, assignment number 1 package, assignment number 2 package, assignment number 3 package, and then you just use the packages. Oh yeah, and especially if you have one assignment that builds off of another, which you don't have in this class, so you don't have to worry about it. But to emphasize on data encapsulation, let's see the sample class first. So we have this sample class. It's going to be called body. This is the implementation here. We got public long, public string, public body, public static. This looks similar to the other class we had. Problem, all of the fields are exposed to the change by everybody. And this is the point I was making before. You don't want to necessarily make all these public, because anyone who wants to can go and change them. So to emphasize the data encapsulation, and this is another word of object orientation. You guys know the, what's this, API, the 4 component, I had to count, the 4 components of object orientation. Do we know the, oh, do you know it already? I gave it away a few seconds ago if you were watching what I was doing. Object orientation, I don't have a pen, is, so you can summarize everything associated with object orientation in one small mnemonic. It's a pie. So A space PIE, pie, like a piece of pie you eat. A stands for abstraction. P is polymorphism. Paul, on the way home every day, 20 times, polymorphism. That's where I had the problem with the word. I is for inheritance. E is for encapsulation. And I've actually talked about everything except for, well, I actually talked about abstraction, I just didn't point it out. But to kind of quickly review, which is not a bad idea for the first day, abstraction is created by objects, abstract data types like queues and stacks. Abstraction exists in non-object-oriented languages as well. We've seen it. If you've taken a data structures course, it's all about abstraction. Memory abstractions through variables. That kind of feature added to the environment, polymorphic behavior, or the P, is when one object can morph into another object. When we can send C, that's the example I gave you with C out. Actually, CN works the same way as well, and from C, C++. We don't have either CN or C out with Java, by the way. But, that's the best example I can come up with right now. We can have, actually I can come up with a better one for Java. We can have constructors that take on integers and floats and doubles and everything. And objects can be instantiated with any number of information or any type. So if we had an object called a stack, we could put numbers on a stack, we could put letters on a stack, or a queue, or something of that nature, and that would be polymorphic type of behavior. Inheritance, one class which facilitates reuse. So everyone says, object oriented is about reuse. It is, but reuse is a byproduct of inheritance, if you think about it. Because when we were inheriting, without inheritance, we don't really have reuse. Yeah, okay, so you can use the same class over and over again in different driver programs. That is kind of like reuse. But to build a hierarchical structure a functionality without having to reinvent the wheel. That's reuse in terms of an inheritance. And then encapsulation, well, here's the last point actually to make. Encapsulation is taking and using the private to hide. It's also referred to as information hiding. So sometimes you'll see a textbook that says, oh yeah, and it has all this stuff associated with object orientation, like information hiding, reuse. It's just other words for a pie, essentially. The 4 components. Because encapsulation is information hiding, and inheritance is reuse, in theory. So an encapsulation kind of like says, hey, this is an engine. You know, when you talk to people and you say, well, what do you got in your car? Well, I got an engine. I got doors. I got a roof. I got a trunk. What about that engine? You don't go, you know what? I don't even know. I would not even be able to tell you off the top of my head how many parts are in the engine. I don't think there's anyone sitting in this room that could probably do that unless you're a mechanic. And even a mechanic might be challenged with that question. But instead, we hide the information, we encapsulate it with the abstraction. So all these words actually work together. We encapsulate the concept of the engine with the abstraction of the name engine. So we know that this is a classroom. I don't have to say, well, there's chairs and a board and a... No, it's just a classroom. So when we say a body is just a body. So every object is encapsulated in itself, and all we have to really worry about is what's called the public interface. And the public interface is what we see in our driver program. And the public interface are those methods. So if you see a driver program that's changing data, bad design. You got a driver program out there that says, pencil1 p1.color is equal to red. You're changing the color of a data member of a class outside of it. It's legal. You can do it. It's legal. But in terms of programming practice, it's better to go set color, change color, get color, and not use those variables, because then you're not encapsulating anything. You have to, if you remember back when you first started programming, and they say, well, you pick variable names that you can remember, because you got to remember all of those names. And then you learned about arrays, and went, instead of having A1, A2, A3, A45, put it all into one array, call it A, and go for each one of the different, indexes of A to get up to 45, and you encapsulate. That's encapsulation. You took 50 variables and you made it into one. Encapsulated it all, and you gave it structure. So you're doing the same thing with the objects. You're taking tons of data, and you're encapsulating it with 5 or 6 methods. You can remember the methods. Set color. So I know set color, it changes this method, it changes this variable, this variable, this variable, this variable, this variable. So you don't go out in the main program and say, okay, I'm setting color. So color number 1, color number 2, color number 3, color number 4. Just call it set color. It does everything for you. And so this is an example of how you can take and make it private, and then inside of the member functions. And we're using this in here. We got a lot of stuff going on in this example. So I'm actually not a fan of this. I think I mentioned that before. And I don't know, I hesitate taking this out of this lecture so early. But unfortunately then people get afraid of things they don't see, they've never seen before. So sometimes if you see the word abstract, even though we're not going to talk about abstract classes in a while, and you see this, we're not going to use this for a while, all of a sudden it's like, oh, I remember this. I remember abstract. So emphasize on data encapsulation and improve on the previous sample class with accessor methods. We've got the private ones going on here. What did we do here? Public methods down here. Now the ID number and the name of orbits are read-only outside of the class. Methods that access internal data are accessor methods sometimes. What do we do here? How can you access the fields? These are the fields. Yeah. Well, you're supposed to put them in here. Not everything belongs in the methods, though. Some of the stuff, it's okay. You don't have to put everything in the methods. You can actually have some of them outside of it.
So for the first one, all the variables were public. Have access for using the encapsulation.
We made the data private so that we could use the methods. Yeah, so we could use these methods here to get ID, get name, get orbits. We're using the methods to get and to modify the data that we're keeping private.
So the one which is private, we are making public.
We have taken this and we changed this to private and we got this and then we went, well, how are we going to change this stuff if it's all private? So then we went to this and added some methods. This is where that concept of accessors and modifiers, and that's why I was calling it an accessor method. I don't like that terminology. I use the get and a set. So, which is in this lecture. Which there's no get, there's no set. There's just some gets in here. So we could add some sets along with the gets. But yeah, you're going to set something. You're going to get something. The word accessor and modifier, it's just too cryptic. I think, I don't know. But what we're doing is we're manipulating this data through the methods instead of just changing the data. You know, it's kind of like if you had a person object, and the person object had an age, and you could just go, hey, I'm 25. Now I'm 24. Okay, now I'm 30, you know. And then there's no rules. People just change their age. But then you could build a method. The rule says if every 1 year anniversary of your birth date, you get a year older, and you can't change that. I don't know, maybe you can. You can lie about it. But your method, your object method to increment the age is working, whether you think so or not. Which is forcing behavior and the integrity of age. If we left this public, we could just say, hey, now you're 12 now, you're 13, you're 21. Where'd that come from? So there's no rules to enforce. So some of this encapsulation protects the object and creates some rules for the objects, like, you know, incrementing values by increments of 5 or something, or making sure, you know, for error checking as an example, you're not setting a salary to -5. Oh, so I'm paying you $5 if I work here? Instead of you paying me something, hopefully more than $5. So it just sets the logic. To emphasize on the data even further, modify on the previous slide with methods for setting. So this has got the gets and the sets. Here's another interesting trivia thing to walk home with, is that people like to group them together by type. And then some people like to do all of the accessors first and the modifier second. I don't care. I mix and mingle. Actually, I like to put them in get ID, set ID, get name, set name. I get to put the gets and the sets. I put them in sets. That way I know I have one to get it, I have one to set it, I have one to get it. Other people like this, get, set. But then I can remember which one did I do. You know? So it's all personal style. Note, now users can set the name and the orbit fields, yes of course. But the ID is still read-only. Well, it's protected, it's static. We're not going to do anything with it anyway. Making fields private and adding methods to access and set them enables the users adding actions in the future. So you need a new behavior, you just add a method for it. This actually sets a nice template for growth and for modifications, and it makes the code more readable. If you've all heard of the concept of spaghetti code, break up this pattern and don't use methods and set everything in blocks. You've got spaghetti code. You don't know what spaghetti code is? Oh, in the States they call, you know, it's like when you first learn C and you have everything all over the place. That's when, this is when they teach you, you'll put all the variable declarations and initializations up front. And then you do all of the prototypes of all your functions. And then you do the main, and then you do the function implementations. That's not spaghetti. That's real nicely formatted. Spaghetti is, oh, here's a function. Oh, here's a prototype. Oh, here's a... It's like, you know, plate of spaghetti when you put the sauce on there with the noodles. And now I'm getting hungry, and you got pieces of... You got, well, this piece over here has got a mushroom, and there's no mushrooms on this side. there's some cheese over here, but there's nothing over here. It's all messed up. You can't find anything. That's spaghetti code. You could do that with classes, actually. So the goal is not to create spaghetti code, essentially. And don't forget that the private modifier on the data field, when necessary, put it on there. Don't. The default access modifier for a field is package, actually, package level. Okay, so how the virtual machine located classes. Interesting. How to tell Java, the virtual machine, where to find your .class files. Answer, set the class path. As I said before, in fact you noticed in my Windows I didn't have a class path set. You might not actually need to set a class path. You need this when you have stuff in multiple directories. Or you have packages. You're using packages with multiple directories and multiple locations. And you need to tell the JVM where is everything. It's kind of like the package for the JVM. So class path is a collection of all the directories and archives files that are starting points of locations of classes, so it knows where to look. The reason why you don't need this in Eclipse is because there's a parameter that's automatically set for you. Just like all those other fancy Visual Studio, when you can set parameters. Where's my working directory? It's workspace. Everything inside a workspace is where they're going to look, where Eclipse is looking for. And it's already, the class path is set to workspace for you by default. So you can avoid some problems. And I have had students who, just did what I did in class with a command prompt. Actually, I have a class path set on this computer. But on some other computers, you're sitting there and it's not only one directory, you're going to get, can't find this, can't find that. That's the most frustrating thing in the world. You can fix it easily if you don't want to change your environment variables by actually typing the real path. And if you have installed everything and you got 1.564 subdirectory, it can be a lot of typing. It may not necessarily be the most efficient way of doing it. Although I've seen some elaborate batch files. And each one of the files has got this whole preface, this whole path in front of it. That's just a waste. Just set a class path. Here's the other thing on Windows, and one thing to remember, on some versions of Windows XP, and I don't remember which ones it is, you actually have to reboot the computer after you change the path and after you change the class path. Remember that when you go in and you get frustrated because it's not Java-C bad command or file name over and over again, reboot the computer. Because the environment variables may not necessarily have been taken, and I want to say that it was the home version that did that. The only problem is it doesn't work the same way with all versions, so it causes mass confusion. Okay, when you're supposed to, no, I think I talked about this stuff already. These are all the different ways that you can specify, anyway, just set the class path. You don't have to do any of that stuff. Setting the class path, here it is. Tedious way. Set the class path. Oh god, you see this on a lot of source code examples. You see this as well. There's an option on Java-C to actually type in a dash class path and then the path. Why do it 100 times every time? You know how many times you compile something? Just do it once. And here's the you can go through, download the slide set. Actually, I would prefer that you use the tutorial. Actually, there's one on setting the class path and the environment variables. It's going to be a little bit slower, a little up to date. It's going to show you more options in this well. So. Naming conventions. I kind of talked to you already about how classes should be in capital letters in the beginning. Package names should start out with lowercase letters. So we always see Java as a lowercase. That will cause you an error. Well, actually it won't. It just won't use it. It's looking for lowercase. If it's lowercase, if it's not lowercase, you want to use uppercase. It's case sensitive. Everything in Java is case sensitive, by the way. Class names start with uppercase letters. We already covered that one. Avoid name conflicts with packages. That's why. If packages are lowercase and class object names are always capital, you never have conflict with the same name. And avoid name conflicts with standard keywords in Java system. I don't believe you can call anything Java. I don't believe anyone's ever tried. I don't know. I've never tried actually, but there are some keywords that you would think people wouldn't use, but they try to use them. Like class. You can't call your class class. And variables, fields, and method names start with lower case letters, and they go with the. Here it is. Oh, is it in here? Multi-word names. No. And I forgot it already. What was this called again? Campus? Camel case. Yes. I'm going to forget it. Again, tomorrow I'm going to ask you again. All uppercase letters. Constant names are usually uppercase letters. Example, pi. Multi-words are camel case. Static. Okay, exceptions. We have class names start with upper letters, end with exception, with normal exception, error, uppercase, fatal error, out of memory. Actually, you'll see that Java's actually all this standard stuff is using those conventions. So. Supplemental reading. You don't have to if you want to. I believe the links still work. Let me take a look here. Make sure the links work. If they do work. What is an object? What is a class? What is an inheritance? Java tutorials are still alive and they're still supported. And they were all transferred. They were all written by somebody. They were all transferred over to the Oracle site. So, if and when in doubt you see a link and it says Sun, change Sun to Oracle. It's practically in the same directory location. So it might actually work for you. So. And let's just cancel this. Let me close this down. I believe that was the last slide, actually, but let me just make sure. Yep, it was the last slide. So mission accomplished. We actually went through lecture 3. So, as I was recommending to some people at the break, and I don't know if you came back before that, we have another day of this tomorrow. We're going to start at 10 o'clock in the morning. Probably about the same length, maybe, unless I finish early. I have 4, 5, but I got a ton of examples to give you. And I got assignments number 1, 2, maybe 3. I'll probably just do the first 2. Go over that. Actually get you started on that. So if you have a computer, you want to be productive, bring it. Go home tonight, maybe install your Java, install your Eclipse. That way, if you have any problem, you can actually bring your computer. I can help you. You can say, look, it doesn't work. And I can say, you didn't change your class path or something. And maybe I can fix the problem for you. If you haven't signed the roster, sign the roster. I don't believe the roster is still with us. Maybe the roster was before lunch. I don't know. Anyway, we're done. See you tomorrow. Thank you.